Now that all the preparations are finished, it's time to get started on your workpiece. Start by switching on the machine. Go on to set the revolution per minute variation and the feed in accordance with the case at hand. Next, move the carriage back and forth to check if it is jammed. Once you know that everything is in order, go about setting the workpiece in the jaws. Using a piece of chalk, demarcate the length of the workpiece to be held outside the chuck jaws. Start by adjusting the chuck jaws to accommodate the raw material. This particular lathe machine houses a 3-jaw self-centering chuck. Use a chuck key to diverge the chuck jaws. Turn the chuck key in any one of the keyholes available on the peripheral of the chuck. Open the jaws enough to house the diameter of the raw material. Mount the unprocessed workpiece, leaving the marked length outside the chuck. Ensure that workpiece is firmly held. Next, place an outer diameter cutting tool in the tool post. Adjust the cutting edge to the center height of the tailstock revolving center height. You can adjust the tool bit height using shims or packing under the tool bit. Here, we have used the packing to raise the level and made further adjustments. Use the wrench to tighten the bolt to hold the tool in place. Move the carriage, bringing the tool bit to the edge of the raw material. Go on to perform the facing operation to cross-check the tool tip height. As you can see, a slight tip-like projection is created as the tool tip height does not match the actual axis of the piece. Correct this by raising the tool tip height by giving some packing underneath the tool by using a piece of paper. Perform the facing operation and check once again. The tip-like projection is now chafed off and we are all set for the turning operation. Commence the center drilling operation. Use the handle on the tailstock to draw back the taper sleeve. Remove the revolving center and fix the drill chuck. Then, loosen the drill chuck jaws and attach the center drill. Use the chuck key to tighten it down. Proceeding ahead, reposition the tailstock. Use a C-spanner to loosen the bolt on it. Push forward the tailstock to move it ahead on the lathe bed, bringing it closer to the workpiece. Tighten the nut on an appropriate position. Start the cycle. The workpiece will start revolving. Rotate the tailstock handle to bring the center drill forward and impregnate the workpiece. Initiate the OD turning operation. First, use a vernier caliper to measure the length of the workpiece up to which the outer diameter turning has to be done. Use the carriage handle to bring the tool post near the workpiece. Advance the tool bit into the work until it just touches the surface of the workpiece. Give it a mark on the required length. Make a trial depth cut to expose concentric surface. Use a vernier caliper to measure this diameter. This diameter will act as a reference to make the ensuing cuts. The next step here is to carry out the zero setting on the cross-slide tile, keeping in mind the reference diameter. Using the cross-slide feed handle, slowly advance the tool bit into the work until it just touches the surface of the workpiece. Continue performing the OD turning operation. Give subsequent cuts till you achieve the required diameter. Of course, you have to plan these cuts so that the final finishing cut brings the workpiece to exactly the desired diameter. Before giving one last final cut, measure the diameter with a vernier caliper. Use the depth vernier to ensure the exact length is turned. The operation sequence planned up to this stage is now complete. Continuing ahead, switch the slide and reset the workpiece by using the chuck key. Tighten the chuck using each of the 3 chuck keys position to ensure a tight and even grip. Once again, perform the facing operation. Go on to bore a hole on the workpiece using a center drill. You will need this hole to hold the workpiece between centers. Now turn the outer diameter of the workpiece just as you had done in the previous setting. Once that's completed, to the required size you can perform the chamfering operation. For the third setting, you need to hold the workpiece between centers located in both the spindle and tailstock. Fix the revolving center in the jaws. Use a job carrier to hold the workpiece. Fix the job carrier with the help of Allen bolts. Clamp it towards the end nearest to the spindle. The job carrier will transmit motion from the rotating chuck to the work. The workpiece is then set between the centers with the carrier resting against the revolving center. Now, the workpiece is all set for taper turning operation. Replace OD turning tool with the taper turning tool. Remember friends, every time you change a tool or reset the workpiece, you must ensure that the tool tip center height matches the axis of the lathe. Set the transverse slide at a required angle to get the requisite taper. In this case, the angle calculated is 9.5 degrees. So we have moved the transverse slide to 9.5 degrees to achieve the desired taper. Lock the slide in position by tightening the nuts. Gradually, advance the transverse slide drum to increase the depth of cuts till you achieve the required taper length. Moving on, get ready to give an external cut on the outer diameter of the workpiece. Change the tool with an external groove cutting tool. Try and use a high-speed steel tip instead of carbide tip tool, as carbide tip are brittle and may break easily during a plunge cut. Ascertain the exact diameter of the groove using a vernier caliper. Continue the operation till you achieve the required depth. Next, replace the groove cutting tool with OD turning tool and perform the chamfering operation. Here, the tool angle is such that it cuts the outer diameter, making a 45-degree slope on the edges, giving it a smooth finish. Moving on to the last leg of the operation. Take out the workpiece by drawing back the tailstock to its home position. Remove the revolving center from the chuck jaws and dislodge the job carrier from the workpiece. Reset the workpiece and ensure the workpiece is secure. Swap the revolving center of the tailstock with a taper-shanked twisted drill. You will first need to append the taper-shanked twist drill in an intermediate sleeve and then fix it in the tailstock. Place a mark on the drill to guide it to the required depth. Start the lathe and drill into the workpiece till you achieve the required depth. Reposition the carriage and remove the drill. Load a boring tool of a diameter slightly less than the diameter of the hole you just drilled. Perform the boring operation. Extricate the chips that might hamper the boring operation and continue boring. Use a depth vernier to check the depth of the bore. Go on to measure the diameter using a vernier caliper. Increase the diameter as required. End the operation by chamfering the internal diameter. Trade the boring tool with an internal groove cutting tool. In order to position the internal groove cutting tool properly, you must take a touch of the tool tip and feed it. Give a plunge cut to the required depth. Once again, perform the OD turning operation on the surface where no threads need to be cut. Perform the chamfering operation and prepare for the threading operation. Use the chart to select the levers and gears in accordance with the thread pitch, since here we are making thread with a pitch of 1.5 mm. The chart suggests that we set the feed lever on the 5th position. Use the gear with 24 teeth, which is the topmost gear on the gear train. Thus, the gear ratio lever is set on the C position. If you are making a right-hand thread, remember to set the chuck in the reverse direction to cut a right-hand thread. Doing so will enable the tool to cut anti-clockwise. Start the internal threading operation by replacing the internal groove cutting tool with an internal thread cutting tool. Give small depth cuts to ensure proper geometry of the thread cuts. Once you achieve the required depth cut, use the Go and No-Go thread gauge to check the quality of the thread. Change the internal thread cutting tool with an external thread cutting tool and perform external threading on the outer diameter of the workpiece. Check the thread pitch using a suitable pitch gauge. Use a brush to clean the surface. Check the external thread cutting with the help of an external thread gauge ring. Last but not the least, perform the parting operation. Load the parting tool by replacing the external thread cutting tool. Mark the length that needs to be cut off and part the workpiece. Use OD turning tool to do internal and external chamfering around the edges of the workpiece. The workpiece is now complete. Remove the finished workpiece. Use this practical guide to lead you through the complete process of machining a component. Here is a recap of the broad steps you need to perform to complete the component. Step 1. Switch on the machine. Step 2. Prepare the machine. Step 3. Set the workpiece. Step 4. Set up the tool. Step 5. Align tooltip height. Step 6. Perform center drilling operation. Step 7. Perform the OD turning operation. Step 8. Reset the workpiece. Step 9. Perform the facing and center drilling operation. Step 10. Perform the OD turning operation. Step 11. Perform the chamfering operation. Step 12. Hold the workpiece between centers. Step 13. Perform the taper turning operation. Step 14. Perform the external grooving operation. Step 15. Perform the chamfering operation. Step 16. Reset the workpiece. Step 17. Perform the drilling operation. Step 18. Perform the boring operation. Step 19. Perform the internal grooving operation. Step 20. Perform the OD turning operation. Step 21. Perform the internal threading operation. Step 22. Perform the external threading operation. Step 23. Perform the parting operation. Step 24. Perform the chamfering operation.